everybody, it's PyFiMan, and I'm making another video on Intro to Calculus. This time we're going to be doing the product rule. So let's get started. The product rule says that if you have a function, h of x, and this function is composed of two functions inside of it multiplying each other, in this case f of x multiplied by g of x, then the derivative of the entire thing, the entire function h of x, is going to be the original first function, f of x, multiplied by the derivative of the second function, g prime at x. You add that to the derivative of the first function, f prime at x, multiplied by the original second function, g at x. So before we get started on some examples, I want to go through some notes about the product rule. And the first thing that we should go through is that the product rule should be used when two functions multiply each other. So the product rule should be only used when you're asked for a derivative of a function where you see two functions multiplying each other, and that's very important. So just remember that. And the next thing that I wanted to go through is that the order does not matter. That meaning that when you do the derivative, you can do the derivative of the first multiplied by the original second. Or you can do the original first multiplied by the derivative of the second. It doesn't really matter. All that matters is that you get the derivatives correct. All right, and the last thing I wanted to talk about was I encourage you to do the derivatives separately and then just plug them into this formula so you make sure that you don't get anything wrong. All right, so let's get started on the first example. The first example that we have here is the function h of x is equal to 3x to the power of 5 plus 7 multiplied by square root x. So, first thing I want to do is I want to identify which function is the first function and which function is the second function. So let's call this first function f of x. And let's call the second function g of x. The next thing I want to do is I want to write the product rule formula so we don't forget, just for this first example. So the product rule formula says we have the derivative of the first function, the original first function multiplied by the derivative of the second function. You add that whole thing to the derivative of the first function now, multiplied by the original second function. So let's just keep that formula up there just for this first example so we don't forget it. Okay, so if the question said find h prime at x, which is the first derivative of x, of the function h at x, then we have to find the derivative of this entire function. And we use the product rule for that because we can tell that there's two functions being multiplied. So the way we're going to do this is we're going to do it one at a time. We're going to do the derivative of the first function, f of x, first. So our function f of x is 3x to the power of 5 plus 7. Now let's find the derivative of this. So let's look at the first term, 3x to the power of 5. Now we know from the power rule that we keep the 3 separate and we bring down n. n in this case is 5. So we bring down the 5 and we multiply it by x to the power of n minus 1. And n in this case is 5. So you're going to get a 4. Now we look at the second term. In this case, it's 7. Now we know from the previous video, and we know in general about derivatives, that when you do the derivative of a constant, it'll always be 0. So you add 0. Now we know that the derivative of this function f of x is going to be 3 times 5, which is 15, multiplied by x to the power of 4. So there we go, we have our first derivative for our first function. Now let's move on to the second function. G at x is equal to the square root of x. Now it's important to not get confused when we see the square root of x. The square root of x is simply x raised to a power of 1/2. So we know that when x is raised to a power, we can use the power rule. So let's go ahead and use the power rule with x raised to a power of 1/2. We know that we bring down the n, and n in this case is 1/2, multiplied by x to the power of n minus 1. And n minus 1 is 1 over 2 minus 1. So now we can simplify the power a bit. We have 1 over 2 times x to the power of negative 1/2. Now if we simplify this to its best terms, we get 1 over 2. We know that the negative just means that it's going to be 1 over x to the power of 1/2, and x to the power of 1/2 is a square root. So we're going to get square root x. And just keep in mind that this right here is x to the power of 1/2. So that's our derivative for the second function, g at x. Now, all we have to do is just plug it into this formula here, and you have your derivative. So we're going to do h prime at x is equal to the original first function, which is 3x to the power of 5 plus 7. Multiply that by the derivative of the second function, which is 1 over 2 square root x. And we're going to add that to the derivative of the first function, which is 15x to the power of 4. Multiply that to the original second function, which is square root of x. Now this is your solution. If you were doing an assignment or a test, you would have to simplify this to its best terms, but this is still correct, and since this is a video and we have 2 more examples to do, I'm not going to simplify it to its best terms. I'm going to leave that for you to do. Alright, so let's do the next example. The next example is the function h at x is equal to tangent of x multiplied by x cubed plus 2x plus 1. So let's say I wanted to find the derivative of the function h at x. Okay, so let's do it. Let's first identify what are the 2 functions, and in this case it's quite easy due to the parentheses. So this first one is f at x. And let's name this second one g at x. Now let's do the derivatives of them separately, and let's do it one by one just like we did in the last example. So for the first function, we have f at x is equal to tan of x. Now, if you watch my last video, or if you just know in general, the trigonometric functions, for the derivatives, you're going to have to remember them. It's important that you remember them since they're used a lot in calculus. So if you remember, the derivative of tangent x is secant squared x. So we have our first derivative for our first function. Now let's move on to the second one. And this function is x cubed plus 2x plus 1. Now let's find the derivative of this. So as we look at the first term, we have x cubed, and we know that any x raised to a power, you can use the power rule. So let's go ahead and use the power rule. We drop the n, multiplied by x to the power of n minus 1, or 3 minus 1, which is 2. Now let's look at the second term. The second term is also the power rule. It's important to notice that this is raised to a power 1. So let's go ahead and do the derivative of 2x with the power rule with the power of 1. So let's put the 2 in the front, and let's drop the n, and the n in this case is 1. We multiply that by x to the power of 1 minus 1, or n minus 1. Now, let's look at the last term. The last term is a constant, and if we remember, the derivative of any constant is 0. So we add 0. Let's simplify this. We know that 3 times x squared is just 3x squared. Now let's go into this one. So we know that 2 times 1 is 2. And we have x to the power of 1 minus 1. And 1 minus 1 is 0. Now we know from algebra that x to the power of 0, or anything to the power of 0 in that fact, is just 1. So we have 2 multiplied by 1 in this case, and that's just 2. So now your final derivative for the g function, or g at x, is 3x squared plus 2. Now let's go ahead and plug that into our formula. And if you don't remember our formula, I'll help you guys out. So the derivative of hx is h prime at x is equal to the original first function, tangent of x, multiplied that by the derivative of the second function, or the derivative of g at x, which is going to be right here, 3x squared plus 2. Now we add that to the derivative of the first function, which is f prime at x, or secant squared x. Multiply that by the original first, this whole thing. So x cubed plus 2x plus 1. And this whole thing is your derivative. Like I said, you can simplify this a bit more by distributing the tangent and the secant, and I think that's about it. So let's go ahead and move on to our last example. Our last example is h at x is equal to ln x multiplied by e to the x. So let's go ahead and identify what are the two functions multiplying each other. This time we don't have parentheses, so it's not that obvious. The first function is ln x, f at x. The second function is e to the x, or let's call it gx. So I wanted to find the derivative of this function hx. Alright, so if you watched my previous video, I did not go over the derivative of ln x, but to get the derivative of ln x, you'd have to do the first principles, and basically it's very similar to the derivative of e to the x or the trigonometric functions, where you have to remember it. And so let me just write it up here so we can remember this. The derivative of ln x is 1 over x. Now, if you are really interested in doing the first principles, go ahead, it's really fun. But if you just want to remember it, it's 1 over x. So let's go ahead and get started. Let's do the derivative of the first function f at x. So the derivative of ln x is what I just said, 1 over x. Now let's go to the second one. Our second function, g at x, is equal to e to the power of x. E to the x, our exponential function. Now if you remember from my last video, Or if you just know it, then you know that the derivative of e to the x is e to the x. So there we go, we have both our derivatives and both our original functions. Now all we have to do is plug it into the formula. So we have h prime at x is equal to the original first, ln x. Let's put this in a bracket, multiply that by the derivative of the second function, e to the x, and we're going to add that to the derivative of the first function, which is 1 over x, multiply that by the original second, which is e to the x. Now I'll simplify this one for you, and you just get e to the x ln x. We're going to add that to e to the x over x, and sorry about that, it's a little messy, but you can further simplify that to e to the x, take that out, and we have inside the bracket, we have ln x plus 1 over x. And this would be our derivative of the function h at x. So that's all I have for you today. If you have a question, then leave a comment, and I hope you enjoyed the video. Thanks.